Thank you. Okay, driven by this conviction, industry are changing the way they do business, influenced by economic need, regulatory frameworks, and social expectation. Chemistry, of course, is the study of matter and energy. They make up the structure of substances, how those atoms and molecules interact, and how their behaviour can be harnessed to transform materials, medicines, and technologies, of course, for the better. Scale, energy, chemicals, toxicity, and waste are all aspects of chemical processes which come under enormous scrutiny. Our 21st century challenge is uncovering ways to reduce these processes efficiently while retaining quality products. The need to measure specific chemicals in a complex mixture, as we've already seen, is also becoming increasingly necessary as the need to reduce waste and track the source of waste becomes also important. Sustainable or green chemistry seeks to develop new materials and processes that, of course, are safe, are environmentally benign, use renewable raw materials, maximise resources by conserving non-renewables, minimise energy requirements, and reduce waste in all stages of product life cycle. Though only 6 are mentioned, there are of course 12 principles of green chemistry that are widely accepted as important. While making and measuring substances remain the core to chemistry, it's how we make the substances and what we measure that is changing the face of chemistry now and into the future. Green chemistry applies the fundamental knowledge, of course, of chemical processes and products that we all learnt at school to achieve practical solutions. Green chemistry is not environmental chemistry, but both subdisciplines can work together to make our planet an even better place to live. Green chemistry is about being proactive, planning and designing processes. Environmental chemistry is more reactive and, of course, after processing. There are many examples of sustainable chemistry in action. The use of biomass to make polylactic acid polymers through the fermentation of corn, or the conversion of carbon dioxide to make useful polymers for carpets, etc., are 2 examples. Of course, we'll hear far more of that as this conference continues. And while significant advances have been made in this area, there's still much to be worked in terms of practice and regulation. What I'd like to do is really tell you a little bit about our approach to that. I want to start with this term chemistry and what does it mean, and I don't know if how you find it in your country, but in our country, chemistry isn't looked on as something that's actually neither green nor healthy nor advantageous for it. The latest commercial that we see talks about fats in the body and how these fats give off harmful chemicals. This idea of harmfulness is something that I think green chemistry can play a significant role in changing the way society thinks of chemistry, and I think it's really important for where we go forward. Chemistry, of course, as we all know, is an enabling science and something that does provide a lot of benefit to us all. So if I could start by just talking a little bit about chemistry at Monash and in particular green chemistry. We were established as a strategic research direction in 1999, and there were 15 research groups that were invited to join us in this. We secured some government funding through the Australian Research Council scheme in 2000 as a special research centre, and we came up with the name Centre for Green Chemistry. Hopefully many of you in the audience might have heard of Monash's Centre for Green Chemistry. Go forward a few years, about 2004, and Milton Hearn, who many in this audience probably knows as an exponent of green chemistry, was made director of that centre. That centre did many things. In fact, it did far too much, so the external review in 2004 really came about. The government came in and said, it's great what you're doing, but you're going to need to start to tighten your areas of expertise in this. About that same time, we also had our first appointment in green chemistry. Kay Sato, who's in the audience, Kay will talk to you a little bit later today on some of the research that he's undertaking. And for over that period, that $9 million went a long way, and that government funding ceased in 2009. What we then thought was, how do one take green chemistry at Monash from something that is simply an academic pleasure to something being far more than that. And with that came the concept of Green Chemical Futures, or the Green Chemical Futures Initiative. In 2011, we managed to secure $75 million of federal government funding to develop this project. The project develops a lot around a building, but it's also the rest of the initiative that comes with it. And that was backed up by some state government funding of $26 million for the Victorian Centre of Sustainable Chemical Manufacturing. It's a tongue twister. VCSEM isn't much better, but that's the name in which it goes by. This was a partnership that came about through bringing together three types of groups. PACEA, which stands for the Plastics and Chemicals Industry of Australia, CSIRO, which is our national scientific body, and the EPA, which is our regulator. I was appointed as the interim director in 2012, and from there we've sort of developed further into this. We've had a number of centres join the initiative. I'm going to tell you a little bit about our Doctoral Training Centre that we've got established as well as having a look at our new building. So how does green chemistry fit into what we do in Monash? Well, it's more than just single groups doing work in the area. It's fairly endemic in what we do at Monash University. You can see here by our mission statement, particularly this bit here, that the school has a broad research base that emphasises the chemistry of sustainability and how it really affects areas in materials, synthetic, analytical, and that green chemistry. In terms of this as well, it's a research culture that we have in sustainability. We try to do a whole lot in industry engagement, which I'll talk a little bit more about, and a little bit in the area of community involvement. This is our new building. This is the Green Chemical Futures Initiative building. It's probably the best looking chemistry building you've ever seen in your life. I know it is in mine. The idea of the building itself is that it's at the heart of our forward thinking in chemical sciences. It's there to invite both students and researchers to explore the possibilities and, as Ingrid said earlier, to stretch their minds, marrying learning with innovation in that. You can see there are two floors down the bottom here, which will be all our undergraduate teaching, and two floors at the top up here, which is for research and translational research as well. It fits together sort of like this. There are three components to what we're doing under GCF. It's really about the School of Chemistry and our Department of Chemical Engineering coming together. It's important, I think, to have the marry of those two disciplines in order to come up with useful solutions. Under GCF, we have three different areas. We have the research area, the education area, as I've just said, the Victorian Centre for Sustainable Chemical Manufacturing. I'll talk a little bit about these as we move along, and they are all underpinned by something that we're developing now, which is in research training. Again, Ingrid brought up the idea of some places, Massachusetts wasn't it, that was doing something in this area. We're doing some, I think, some really nice things as well. And I'll tell you a little bit more about them as we go through. In terms of the area of research that we deal with in terms of green chemistry at Monash, here's a non-exhausted list of what we do, from ionic liquids and how one uses them in sustainable chemistry through to catalysis, both homogeneous and heterogeneous, bioseparations, looking at sensors and diagnostics. Kay will talk a little bit later on about his polymer work. One of the areas that he's right into is self-healing polymers. We're really big in the area of renewable energy, energy storage, and using CO2 in terms of utilisation and sequestration. We come from a part of the world where brown coal is used as our energy source, so anything we can do to help green that process up, I think, is really important for us as we move forward. Of course, through the self-assembly, hydrogen storage, and water science as well. What I want to bring to your attention is this Victorian Centre for Sustainable Chemical Manufacturing. It has a mission. The mission is to find solutions for industry in green chemistry and engineering that increase a company's profits, competitiveness, and reduce their environmental impact. A couple of things here that are important. Again, the EPA and PACEA are heavily involved in this as our regulating body as well. The other thing that's important is that VCSEM, or the Victorian Centre for Sustainable Chemical Manufacturing, was too much of a tongue twister for much of industry to understand what we do. So we've actually gone to this point of talking now about sustainable manufacturing solutions as the outcome. There are three aspects of this that we deal, two aspects at the moment that we deal with. One is in the area of food and the other is in chemical manufacturing. And what we've employed is a series of, we call them sector specialists. They're business development managers, essentially, that deal solely with those industries. They've come from those industries, and so our understanding, the way that we're working it is that their understanding of that industry should help break down some of the barriers that are really important to what we do. As we said, there's a lot of examples of green chemistry. Yeah, there's a lot of examples of green chemistry that's successfully implemented. Here's a couple through Pfizer, DuPont, Monsanto, of course, and there are others that have dealt with in this area. But when you really think about it, given how long green chemistry's been around for, the amount of examples is certainly not exhaustive, and I think a lot more can be done. The awareness of green chemistry, particularly at that small to medium enterprise level, I think is still waning. While a lot of the big companies understand green chemistry and where its potential might lead us, a lot of smaller companies don't have this same luxury. And so this Victorian Centre for Sustainable Chemical Manufacturing is really about trying to educate smaller industries on how we can use this. It does it through this type of process. It's probably a little bit over-fashioned, but it's the way it goes. Monash University and CSIRO are the two research partners in this, so they're the ones that do a lot of the research associated with it. Industry come to us through the sector specialists who are out there integrated with them to develop projects. These projects go through a technology leadership committee that link in who should do the work, what capabilities do we have, what capabilities do we need in order to do this, and then that also then leads to the education platform, which is to look at workshops and seminars, networking events, to try to get people more infused with the idea of green chemistry. Where has this led? Well, the chemical industry, of course, is a big one. The Plastics and Chemicals Institute have done a study that suggests that 106 of the 109 industry sectors in Australia use chemicals in their supply chain. So chemistry is a big part of much of the business that goes on in Australia and, dare I say, all around the world. You can split it up into three areas, of course: basic chemicals, specialist chemicals, and consumer chemicals, and a lot of those are very important for making us look good, feel good, and alike. Some of the project areas that we've been looking at under VCSEM are written down here in very generic terms, but the main point is we've had success with the sustainable manufacturing solutions, and that we've been able to attract over $4 million worth of industry-related support in the last 2 years through this process. The way the system works is shown on this slide here. There's, as we said, the sector specialists that do a lot of the work in this area for us. But what happens is through this process, the lead scientists at both Monash, at the Clayton campus, which is more material science at CSIRO, and the one at the Werribee here is more food, then distribute the projects based on that. So it's trying to bring as many people from chemistry and chemical engineering together to solve these problems as possible, rather than trying to be very isolated with only a finite number of groups involved with it. The other thing that I think is important to understand is when talking to industry is to know the groups that you're talking to. If you go and talk to the food industry and you start talking to them about chemicals, they'll tell you quite clearly that they don't use chemicals in anything that they do. They use simply ingredients. So trying to break down barriers, cultural barriers in how they perceive what they do versus what they actually do is an interesting part of the process. Linked in with the idea of the VCSEM and the research projects is a research platform idea. And here we have over $5 million worth of investment in 3 platforms. The platforms are intensive synthesis and continuous processing, advanced isolation and separation techniques, and a continuous process monitoring type of platform. So by having these platforms, what we're hoping and what is actually happening is industry is coming to us to use the equipment that we have to ultimately better their processes. We have a number of research centres that all integrate together. We've spoken about green chemical futures. We also have a water study centre that deals with the water aspects of that sort of work. And as we said before, integrated with the Australian Centre for Electromaterials Science, which deals with a lot of renewable energy type of projects. If I could sort of summarise where we are with GCF. GCF is linked in through the Victorian Centre for Sustainable Chemical Manufacturing, EPA and PACEA, to look at a range of different sorts of what are we going to call it, research areas, let's say. Linked into GCF is a number of partner organisations that we have. Waseda is a very strong partner for us. University of Bath is now quite a strong partner for us, and Yale has been a very good partner in the end. But at the end of the day, what we're trying to do, and I think a lot of people are trying to do as well, is trying to build these centres together to try and have, I guess, at least a consistent approach to green chemistry and utilising that global expertise in moving everything forward. But you can see it goes from sort of talking about research through to conversion into industry and then the deployment into that manufacturing side of life. We also do a lot of work in the education space. I've just taken something out of Kay's actually runs this course for me, out of the unit guide for this course. But you can see quite clearly here that we have a number of units at the junior years of our undergraduate program. We put green chemistry in there in a very, very endemic sort of way, building that up to more senior years with specific courses in sustainable chemistry and engineering and the like. So what we're trying to do is, I guess, a cradle-to-cradle approach, not only in terms of green chemistry and what it's about, but also in terms of green chemical education as well. Started off early and worked through to postgraduate and beyond in terms of training. Finally, what I'd like to do is talk to you a little bit about our doctoral training centre and where we're going with that. So this idea of having people or scientists who know a lot about chemistry and green chemistry and its potential is great, but it's only great if those people can also start to talk to the engineers, to the business people and the like. And it's only, I think, with a holistic approach that this is possible, and this is what we're trying to hope to do through our doctoral training centre. So at the moment, it's there to support 20 industry-focused PhDs with a couple of postdoc fellows, but ultimately to look to benefit our whole cohort of postgraduate students in chemistry and chemical engineering. The idea is to deliver high-quality people for the future, so make my graduates more employable than the university next to me. And we do this by providing industry experience and specialist training modules. That's really what it's about, talking about that full spectrum of education. At the end of the day, we're also there to deliver a series of annual events and activities, including careers convention and the like, to really promote those opportunities, both to industry, but also to potential PhD and master's students as well. So what we're about is trying to train the best industrial professionals. That's really what we're trying to do here. We provide them with scholarships and we provide them with that opportunity to work in industry as part of an internship, which we think is really important for them in developing or integrating green chemistry into those industries. Number of the technical types of topics that we're into, they're the sorts that you would tend to suggest that we would do, but also a range of business topics that we're also very much interested in putting into place for these students as well. So having a high quality recruitment pool, having industry and academia collaborate and participate together, I think is really important for us. to having access to specialist R&D capability and innovation through our research platforms is helping us do things by having really good case studies, being able to then show that to the rest of the world, and of course also providing industrial training and best practice, not only from an institutional level, but of course in something that's a bit more industry focused in what we do. These are the companies that are involved with our doctoral training centre at the moment. So as you can see, there's a large consortia of them, and every day as we're progressing this, there's more and more interest from industry in what we're doing here. I think they feel that there's a really strong need both to understand more about green chemistry, but also to have students with the right blend of science background and maybe some business prowess that allows them to move seamlessly into those sorts of industries. I don't have far too much more to go apart from saying to you this is the building as it's being constructed. It will be finished at the end of this year, which is great for us. The process of the whole GCF concept is coming together quite nicely outside of this, but the building will be an exceptional part of what we're doing there. The space within the building, as I mentioned before, it's 50% undergraduate teaching in the chemical sciences, and particularly green chemistry and the like. We'll be doing about 25% of the floor space will be dedicated to pure research, if we want to call it that, more fundamental research. And the other 25% of the space, which is about, 2,500 square metres-ish, is for translational research, so bringing companies in and doing research with us, not only through the Doctoral Training Centre, but of course through the VCSEM. And the building, as we've got it, has been validated against Oxford, Caltech, Nanyang and Ohio State as buildings that are quite innovative in their approach to the chemical sciences. Also, the building has all these new spaces, etc. I don't want to bore you with those sorts of details. All I wanted to do in this address was just really to highlight what we're doing and saying that it's more holistic than simple isolated projects. What we're trying to do is put the whole system into place so that we end up with a better outcome for green chemistry. Finally, if I may, I might just stop at this slide here, which sort of says if you're ever in Victoria, come and visit us at Monash University. Monash is in the southeast suburbs of Melbourne down here. So this is the bottom of Australia that we're talking about, or the top if you flip the world upside down. So this is Victoria. Melbourne's over here. Beautiful wineries that you can explore. Places that you can go bushwalking and the like. A very cosmopolitan city. Oh, okay. Oh, I'm just about finished. Little fairy penguins down here on an island, and this beach over here is called 90 Mile Beach. It's called 90 Mile Beach because it's 90 miles long. It's a single beach that's 90 miles long, beautiful white sands, etc. So a wonderful place to visit. And of course, as the gentleman just said, I have more time, but I have nothing else to say. So I'd like to thank you for your attention, and I'd be happy to take any questions if you have them. Thanks very much.
All right, ladies and gentlemen, does anybody have any questions? Please raise your hand and I'll bring you the microphone. Okay, we got one up here.
I'm Dr. J.S. Yadav. I was actually director of Indian Institute of Chemical Technology. I'm sure probably you visited us. Now the building is looking very fancy.
Yeah.
Does it have the green chemistry concept, like less energy?
Yeah,
No. Good ventilation.
Really good point. Where possible. So the building has a 5-star green rating, which in Australia is literally as high as you can go for that sort of building.
Very specific. Whether it has the principle of green chemistry means
can
consume less energy and provide the same effort.
Yes, so where possible, and where practical, because we have a budget in which to work with the building, that's been applied. So a lot of natural materials have been used. Much of the vinyls and the like have been sourced from places that
people built in Switzerland is completely through the solar energy. That.
Not completely through. No, we
So
don't, it's passively heated and cooled,
Right.
but we haven't generated a complete photovoltaic system
it's a
for
good idea
it
to
yet.
think about.
Absolutely, yeah. It's also a very expensive idea to do. Yeah.
Okay, any other questions? Okay, right here.
Yeah, Shen Hong Dai from Taiwan. My question is, the green chemistry, what level is graduate student or undergraduate student? In what level, what year would be the best way to introduce this kind of courses to the student?
Yeah. So interestingly, we've been very successful, particularly in Victoria, in promoting green chemistry as a future. I say that because one of the electives that students can do at high school is an elective in green chemistry. So a certain number of students already have an idea, just based on the 12 principles, of what green chemistry is. We then take that knowledge and develop it further at the first year level. The second year level, we don't identify it so much as green chemistry, as we do environmental chemistry and a number of other areas, refocusing that again at the third year level through our sustainable chemistry courses and courses in energy and the like. So we're sort of always building this in terms of a culture or a way of thinking, rather than just saying this is this somewhat new flashy subject. You know, it's really about the good chemistry. You know, green chemistry is good chemistry. You teach good chemistry. That's, I think, what it's about.
Next question I have is the industry come to university asking for help is through the professor or through the department or through what is the connection?
If we were just to sit there and wait for people to come to us, we wouldn't get the level of activity that we do. Our sector specialists are incredibly important for what we do. So they're out there pushing our capabilities and discussing with their industries how we could help them better what they do. So it's not always a case of saying we're going to change everything that you do. It's a case of taking little steps at a time, showing them the benefit of a new process or a new way of doing things. Lots of electroplating gets done in Victoria. Electroplating, of course, has waste streams like there's no tomorrow. They're quite bad. With the help of the state government, again, we've been developing new processes for electroplate, or to clean up the waste associated with them, which a lot of those companies are finding quite beneficial. But it's not a case of us waiting. It's a case of being very proactive with industry in this regard.
Thank you very much.
Okay, any other questions? Okay, there you go. Thank you.